students, this is Sivakumar, 10th standard mathematics, chapter number 3, exercise 3.3, problem number 1. Find the LCM and GCD for the following and verify that f of x into g of x equals LCM into GCD. You are given two polynomials. Consider the first one as f of x and the second one as g of x. From f of x and g of x, you have to find out the LCM as well as GCD. Now subdivision number 1. 21x squared y, 35xy squared. Right. Now I take 21. After that 35. Factorize. Prime factorization you know very well. 21 can be divided by the prime number 3 table 7 times and 7 table 1 time. Until you get 1, keep on dividing. Each and every number must be a prime number. You know very well about the prime number. Right, now 35 can go 5 table 7 times and 7 table 1 time. Now take 21x squared y, that is equal to 21 can be written as 3 into 7 into x squared y. Okay, this is into, it is also into. Otherwise I do one thing, I write 3 and 7 inside the brackets, then x squared y. Okay, now 35xy squared can be written as 5 into 7 and xy squared inside the brackets. Now we can write LCM, after that GCD. LCM equals, LCM you know very well, write the common factors. The common factors are 7, here 7 is common. Then x squared x. So which one is the greatest? X squared. So write x squared. Then y and y squared is greater. Then 3 and 5 should also be included. Again I tell you, 7 common. Then after writing the common numbers, the left out numbers, what are they? 3 and 5, that should be included. Then okay, it is a monomial. No, 21x squared y is a monomial, 35xy squared is also a monomial. We haven't applied any identity. In that case, x squared x, which one is greater? X squared, that should be taken. Y squared, which one is greater? Y squared. This is LCM. Just multiply 7 3s are 21, 21 5s are 105, x squared y squared. LCM over. Now GCD. GCD, that is the greatest common divisor. Common only have to. 3 here, no 3 at all. Here 5, here no 5 at all. Here 7, here also 7. 7 common. X squared x, which one is the least? X, that is common. Y squared, which one is the least? Y, that is common. 7xy, that is GCD. So LCM and GCD over, first part over. Then you have to verify f of x into g of x equals LCM into GCD. Now take f of x into g of x. G of x. First one I consider this one as f of x. I write over here. Let f of x, that is equal to 21x squared y, and g of x equals, I consider 35xy squared. Okay, we can take that f of x into g of x. F of x, that is 21x squared y into g of x 35xy square equals 21 into 35. I do here 21 into 35. You know multiplication, 5 ones are 5, 5 twos are 10, 3 ones are 3, 3 twos are 6, 735. 735. X square into x, that is equal to x cube. Y into y square equals y cube. LHS over. Let it be number 1. LHS over. Now I am going to take RHS, that is LCM into GCD. LCM here it is what it is, 105 x squared y squared into GCD here it is 7xy equals 105 into 7, that is equal to 735. X square into x equals x cube. Y square into y equals y cube. Look at that. 1 and 2 same answer. From 1 and 2 it is verified that f of x into g of x equals LCM into GCD. From 1 and 2 it is verified that f of x into g of x, that is equal to LCM into GCD. So problem number 1 subdivision 1 is over. I will be teaching problem number 1 subdivision 2 in the next video. Thank you children. Hi students, this is Sivakumar, 10th standard mathematics, chapter number 3, continuation of exercise 3.3. Now question number 1 subdivision number 2. Find the LCM and GCD from the given two polynomials and verify that f of x into g of x equals LCM into GCD. Okay. You are given two polynomials. Consider the first polynomial as f of x, f of x, that is equal to x cube minus 1 into x plus 1. First we can factorize, after that we can take the next polynomial. Okay. Here x cube, here we have 1. Can we write 1 as 1 cube? Since we have power 3, 1 itself can be written as 1 power 3 because 1 power anything is always 1. Here we can apply the identity a cube minus b cube. A, that is x, b, that is 1. A cube minus b cube, that is equal to a minus b into a squared plus ab plus b squared. Which one is a? X. Which one is b? 1. So a, that is x, b, that is 1. Substitute over here. Come on. A minus b, that is x minus 1. A squared, that is x squared. A into b, x into 1. X into 1 is x plus b squared, 1 squared. 1 squared is 1. This part is over. At the last we have one more x plus 1. So we have x plus 1, right as it is. So f of x is over. Now take g of x. Let g of x equals, here g of x, write x cube plus 1. Since we have 3 in the power, 1 itself can be written as 1 cube. Here you have to apply the identity a cube plus b cube. A cube plus b cube, that is equal to a plus b into a squared minus ab plus b squared. Compare a, that is x, b, that is 1. A, x, b, 1. Substitute over here. A plus b, x plus 1. A squared, x squared. A into b, x into 1, x into 1, x. B squared, 1 squared, 1. Now g of x also over. Now write LCM first. LCM already told you, first you have to write the common factors. Common factors, here we have x minus 1, no x minus 1, x squared plus x plus 1, here x squared minus x plus 1, both different. But we have x plus 1 common, correct? After taking x plus 1 common, What are the left out factors? Left out factors, we have x minus 1, we have x squared plus x plus 1, and we have x squared minus x plus 1. This is LCM. Now GCD equals common factor only, greatest common divisor between these two, common x plus 1 only common, so write x plus 1. GCD also over. So LCM and GCD over. For LCM in particular we can simplify. See, x plus 1 and x squared minus x plus 1, these two together, here it is, correct? This itself can be written as x cube plus 1 cube. X cube plus 1 cube. 1 cube is 1. These two x minus 1 and x square plus x plus 1, here it is. Leave off this factor. These two comes from this expression. What it is? X cube minus 1 cube. Right? X cube minus 1 cube. That is x cube minus 1. So LCM and GCD over. Now we have to verify LHS and RHS are equal. F of x and g of x. Consider f of x into g of x. F of x, here it is, x cube minus 1 cube into x plus 1. Into g of x. This is g of x. What it is? X cube plus 1 cube. That is equal to f of x into g of x. Okay, right. F of x into g of x over. Then let it be number 1. Now LCM into GCD. LCM into GCD. LCM, here it is. X cube plus 1 into x cube minus 1. Into GCD. GCD, here it is. What it is? X plus 1. That's all. Look at that. Everything is product only. X cube minus 1, here it is. X cube plus 1, here it is. X plus 1, here it is. Same only. Order only changed. So 1 and 2 are equal. From 1 and 2, it is verified that f of x into g of x, that is equal to LCM into GCD. So second subdivision is over. I will be teaching the third subdivision in the next video. Thank you, children. Hi students, this is Sivakumar. 10th standard mathematics, chapter number 3, continuation of exercise 3.3. Now question number 1, subdivision number 3. Once again you are given two polynomials. Consider them as f of x and g of x. Find LCM and GCD. After that, have to verify f of x into g of x equals LCM into GCD. Okay, x squared y plus xy squared. Next one is x squared plus xy. Let f of x equals first polynomial x squared y plus xy squared. In factorization you have to take the common factor. X squared and x, which one is the least? X is the least. Y and y squared, which one is the least? Y. So xy is common. After taking x and y, one more x will be there. Here one more y will be there. You can verify. Multiply these two, x into x, x squared into y, x squared y. Multiply these two, y into y, y squared. Here we have x, so xy squared. Same only. Next one. Suppose if you have any doubt, I do it in rougher column. x squared x common, y squared y common, correct? Then the terms which is inside the bracket, how I got it, just listen. The first term here we have x squared y, correct? Divide by the common, which one is the common? xy. So one x get cancel, y cancel, which one is left out? X, have written x over here, understood? Plus plus. Then how I got that y? Listen, what's the second term? xy squared divided by the common, which one is common? xy. X get cancelled, 1y get cancelled, which one is left out? Y, have written that way. If you know, you can directly write. Okay, after that, let g of x, that is equal to x squared plus xy, common x squared and x, which one is the least? X. Here y can no y at all, so x alone common. After taking x common, can directly write what should be multiplied with x to get x squared? X, obviously, because x into x squared, like that. What should be multiplied with x to get xy? Surely y only, because x into y xy. Otherwise, x squared divided by x, 1x get cancelled, x, look at that, plus plus. Xy divided by the common factor, xy divided by the common x get cancelled, y, I have written y. Okay, if you have any doubt, you can refer this one. Okay, now we can write LCM and GCD. LCM, that is, first write the common factor. Here we have x, here also we have x, write x. Okay, x have taken. Next x plus y, here also x plus y, write x plus y. These two only common. After writing the common factors, x plus y also common. After writing the common factors, which one is left out? Y alone left out, that should be included, that is LCM. The next step, we can write x and y together, xy into x plus y, LCM over. Now GCD. GCD, already I told you, you just write only the common factors. Here we have x, here also x, so x common. Not only that, x plus y, here also x plus y, so x and the x plus y. This is GCD. So this is one answer, this is one answer. After that, you have to verify f of x and g of x, that is equal to LCM into GCD. So consider f of x, here it is, what it is? xy into x plus y. G of x, here it is, what it is? X into x plus y, x into x plus y, that is equal to x into x, x squared, then y, x plus y into x plus y is x plus y the whole square, that is number 1. And LCM into GCD equals LCM, here it is, xy into x plus y. GCD, here it is, x into x plus y, that is equal to x into x, x square, y, x plus y into x plus y is x plus y the whole square, that is number 2. Both same only, correct? X squared y, x plus y the whole square. From 1 and 2, it is verified that f of x into g of x, that is equal to LCM into GCD. So subdivision number 3 also over. So question number 1 completely over. I will be teaching problem number 2 in the next video. Thank you, children. Hi students, this is Sivakumar. 10th standard mathematics, chapter number 3, continuation of exercise 3.3. Question number 2. Find the LCM of each of pair of the following polynomials. You are given 2 polynomials and GCD. You are asked to find out LCM. Listen. Solution. we know that Lcm formula, since polynomial in terms of a, you write f of a into g of a. Suppose you are given the polynomial in terms of x, write f of x. Okay, so f of a and g of a divided by GCD. This is the formula. Okay, f of a, write as it is, a squared plus 4a minus 12 into g of a squared minus 5a plus 6 divided by GCD equals a minus 2. Take any one of them. Factorize. I take the first one. What is the coefficient of a squared? 1, correct? 1 into minus 12. Minus 12. Coefficient of a, that is equal to 4. You have to say the two numbers. Product of the two numbers equals minus 12. And sum of the same two numbers equals 4. So obviously 6 and minus 2, correct? 6 minus 2 equals 4. 6 into minus 2 equals minus 12. Now, for getting the factors, we need the linear factors. Consider the coefficient of a square. What is the coefficient of a square? 1, right? 1 in numerator. This is a shortcut method for you. Then into what variable we have? A. Just put a. So 1 into a plus 6. 1 into a minus 2. Then write the second as it is 5a. Sorry, this is 5a plus 6 whole divided by a minus 2. Now a minus 2 get cancelled. So a plus 6 into a squared minus 5a plus 6. For factorizing, I have taken the first polynomial. Even you can take this second polynomial. Definitely a minus 2 and a minus 2 get cancelled. We are getting the different answer. That is also correct. Okay. Now, so question number 2, subdivision 1 is over. I do one thing. Wait a bit. Or Lcm equals, I do it in one more method, f of a into g of a divided by GCD. This is the first method, this one is the second method. I am writing f of a that is equal to a squared plus 4a minus 12 into g of a, that is a squared minus 5a plus 6 divided by a minus 2. For this time, I am retaining the first polynomial. I am going to factorize the second polynomial. Okay, listen. What is the coefficient of a square here? 1. 1 into 6, 6. And a coefficient is minus 5. Product 6 and sum minus 5. The two numbers are minus 3 and minus 2. Add the two numbers, minus 5. Multiply the two numbers, 6. Since we need the linear factors, consider the coefficient of a squared and write in numerator 1, 1. You just put into a. Write 1 into a minus 3. 1 into a minus 2. And divided by, whole divided by a minus 2. Look at that. A minus 2 get cancelled. So a squared plus 4a minus 12 into a minus 3. Both the answers are correct. Can take any one of them, right? So question number 2, subdivision 1 is over. Then I'll be teaching question number 2, subdivision number 2 in the next video. Thank you, children. Hi students, this is Sivakumar. 10th Standard Mathematics, chapter number 3, continuation of exercise 3.3. Now question number 2, subdivision number 2. Find the LCM of the following two polynomials. And whose GCD is given, x minus 3a. Okay. Solution. Here I consider, here it's a polynomial, it's in terms of x as well as a. You write f of x, let it be f of x, x power 4 minus 27 a cube x. Okay, we can take common factor. Which one is common? X power 4 and x. Since x is the least one, I take x as common. Since we have taken x as common, what should be multiplied with the x to get x power 4? Definitely x cube. If x into x cube is x power 4 minus 27 a cube. Already have taken x as common. You have tried 27 a cube. That is equal to x cube, right, as it is. This cube is only for a, not for 27. So that I can write 27 a cube, that is equal to 3a the whole cube. Correct? Because 3 cube, that is equal to 27. A power 3 is a cube. These two are same only. So this is of the form a cube minus b cube. We know that a cube minus b cube, that is equal to a minus b into a square plus ab plus b square. Which one is a? Which one is b? This is a that is x. This one is b that is equal to 3a. So write this x as it is. Now I am going to apply the identity. Here is identity, a minus b, a x, b 3a. So x minus 3a into a square, x square, a into b, x into 3a. Then b square, b that is 3a the whole square. That is very important, the whole square. That is equal to x into x minus 3a, x square, x into 3a, 3ax. 3a the whole square is 9a square. The square is common for 3 as well as a. So 3 square is 9, a power 2 is a square. So f of x is factorized. Now I take g of x. Let g of x, that is equal to x minus 3a the whole square. Even though it is in the form of a minus b the whole square, you are not supposed to apply the identity a minus b whole square. What to do, sir? Just write x minus 3a for 2 times because of power 2. Suppose power 3, now have tried x minus 3a for how many times? 3 times. Now write the formula for LCM. We know that LCM equals f of x into g of x divided by GCD. F of x into x minus 3a into x square plus 3ax plus 9a square. Into g of x here it is, x minus 3a, again x minus 3a, whole divided by GCD, here it is. What is GCD? X minus 3a. You strike out any one x minus 3, I strike out these two. Okay, that's all. Write x minus 3 and x minus 3a together, x minus 3a the whole square. These two together, x minus 3a the whole square into x square plus 3ax plus 9a square. That's all. You no need to multiply everything. So question number 2, both the subdivisions are over. I'll be teaching problem number 3 in the next video. Thank you, children. Hi students, this is Sivakumar. 10th standard mathematics, chapter number 3, continuation of exercise 3.3. Now problem number 3. Find the GCD of the following two polynomials whose LCM is. Here you are given two polynomials and the LCM. You are asked to find out the GCD, greatest common divisor. Okay. Two polynomials, LCM, you have to find out GCD. I consider the first polynomial as f of x, second polynomial as g of x. Let f of x equals 12 into x power 4 minus x cube. 12, write as it is. x power 4 x cube, which one is common? Which one is the least x cube? So obviously x cube is common. After taking x cube as common, what I have tried here, x and minus 1, correct? X cube into x, that is equal to x power 4 minus 1 into x cube equals x cube. Now g of x equals here 8 into x power 4 minus 3x cube plus 2x square. 8 write as it is. Here x power 4 x cube x square. From these three, which one is the least? X squared. So x squared is common. So after taking x squared is common, what I have tried inside the brackets, x squared minus 3x plus 2, correct? X squared into x squared is x power 4, 3x into x squared is 3x cube, 2 into x squared 2x squared. That is equal to 8x squared, right, as it is. Here, if it is possible, you can factorize the quadratic polynomial. This is a quadratic polynomial, correct? Because the degree of the polynomial is 2. How to factorize? You know very well. The coefficient of x squared is 1. 1 into the constant 2. 1 into 2 equals 2. The coefficient of x is minus 3. Product 2, sum minus 3, the two numbers are 2 and 1. 2 into 1, 2. For getting minus 3, have to introduce minus for both the numbers. Now we can verify. Minus 2 minus 1, if you add, you will be getting minus 3. If you multiply the two numbers, minus 2 into minus 1, that is equal to plus 2. Correct. Now you have to consider the coefficient of x squared. What it is? 1. Write 1 in numerator. Put into. We have the variable x, so put x. So 1 into x, x minus 2. 1 into x, x minus 1 over. Now we know that. Remember the formula. You are asked to find out. Listen here. Not DCD, GCD. Sorry. GCD equals f of x into g of x divided by GCD, sorry, LCM. Here, suppose if you are asked to find out a LCM equals f of x into g of x by GCD. But you are asked to find out GCD. So GCD equals f of x into g of x by LCM. Okay. Write f of x. F of x equals 12x cube into x minus 1. Into g of x, here it is 8x squared. Okay, 8x squared I have written inside the brackets into x minus 2 into x minus 1. You know, not necessary to write x squared inside the brackets. LCM that is given here, 24x cube into x minus 1 into x minus 2. 24x cube into x minus 1 into x minus 2. After that, very easy. 12 table, how many times? 2 times. X cube get cancelled. X minus 1 cancelled. 2 table 4 times. X minus 2 cancel. So after cancelling some terms, what are the terms left out? Here we have 4 and x squared, 4x squared and x minus 1. That's all. So question number 3 subdivision 1 is over. I'll be teaching question number 3 subdivision 2 in the next video. Thank you, children. Students, this is Okumar, 10th standard mathematics, chapter number 3, continuation of exercise 3.3. Now question number 3 subdivision number 2. Find the GCD of the following two polynomials. You are given the LCM also. Okay. Here are two polynomials. I consider the first polynomial as f of x. Let f of x, that is equal to x cube plus y cube. Generally, we are factorizing x cube plus y cube with the help of the identity a cube plus b cube. Here, no need to factorize. Reason, the same term is in LCM. Correct? Both get cancelled directly. So, you no need to factorize. Right as it is. Now, let g of x equals x power 4 plus x squared y squared plus y power 4. I have given the identity already. A power 4 plus a squared b squared plus b power 4 identity is a squared minus ab plus b squared into a squared plus ab plus b squared. This one already I have given. Instead of a and b, you have x and y. You just replace a and b by x and y respectively. That is equal to a squared x squared a into b x into y, b squared y squared into a squared x squared plus a into b x into y, b squared y squared over. Then write the formula for GCD to find GCD. Okay, listen. You can write the formula directly. GCD equals f of x into g of x divided by GCD equals f of x, here it is x cube plus y cube, g of x squared minus xy plus y squared, then x squared plus xy plus y squared. GCD here. Oh, sorry, by mistake I have written that this is LCM. LCM that is given here, it is x cube plus y cube into x squared plus xy plus y squared. So x cube plus y cube get cancelled. X square plus xy plus y square, here it is, these two get cancelled. So which one is left out? This x square minus xy plus y square over. Question number 3 subdivision 2 also over. Then I will be teaching problem number 4 in the next video. Thank you, children. Hi students, this is Sivakumar, 10th standard mathematics, chapter number 3, continuation of exercise 3.3. Now problem number 4. Here given that LCM and GCD of the two polynomials p of x and q of x. Find the unknown polynomial in the following table. In first subdivision you are given LCM, GCD as well as one polynomial p of x. You have to find out the other polynomial q of x. In second subdivision you are given LCM, GCD and the polynomial q of x. You have to find out the polynomial p of x. Okay. Look at that. We have LCM, GCD and polynomial p of x. You have to find out q of x. Listen carefully. So far we have seen a linear factor and quadratic factor, but we have, this is a polynomial with a degree 3. This is called cubic polynomial. How to factorize into linear factors? I teach you the shortcut. Before factorizing this cubic polynomial, I factorize this quadratic polynomial first. I do here. Coefficient of a squared is 1. 1 into 35, 35. Coefficient of a, that is equal to minus 12, right? Minus 12 over here. Product 35, sum minus 12. Obviously the two numbers are 7 and 5. Introduce negative for both the numbers. Now can verify. Minus 7 minus 5, that is equal to minus 12. Add together minus 12. If you multiply the two numbers, minus into minus plus, 7 5s are 35. For getting the linear factors, you have to consider the coefficient of a square. What is here? 1. Write 1 in numerator. Here also 1. Into the variable we have a. So write a. So 1 into a minus 7. 1 into a minus 5. Okay. You are asked to find out q of x. We know that q of x, that is equal to, this is a formula, listen, Lcm into GCD by p of x. Lcm, here it is, we have to factorize. Then GCD, here it is a minus 7, and p of x, a minus 7 into a minus 5, a minus 7 into a minus 5. Now I do the calculation here. Listen carefully. How to factorize? These two a minus 7 get cancelled. Okay. Now go for synthetic division method. This is a new method for you. This method is applicable for factorizing the cubic polynomial. What is the coefficient of a cube? 1. A cube 1. What is the coefficient of a squared? Minus 10. What is the coefficient of a? 11. What is the constant? 70. Why I am doing at the last? Very simple. What is the factor in the denominator? A minus 5. Okay, take a minus 5, that is equal to 0, which implies a that is equal to 5. Consider the factor which is in denominator after cancelling a minus 7. Which one is left out? A minus 5. Take it as 0. What is value of a? 5, because minus 5 comes right hand side, plus 5. So consider this 5 over here. Write this 5 here. Okay. Now here always you start with the 0 only. In this type synthetic division, here you have to put 0 only. Simple addition, 1 plus 0 1. Then 1 into 5 5. Right over here. Minus 10 plus 5, that is equal to minus 5. Multiply these two numbers. 5 into minus 5, that is equal to minus 25. 11 minus 25, that is equal to minus 14. Correct? Minus 14 into 5, that is equal to minus 70. Look at that. Definitely you are getting the remainder 0. So once you get the remainder 0, that is factorizable. What it means? It is factorizable. We can write 3 linear factors. What are the 3 linear factors? For that, you can divide further, or you can stop over here. See, one factor is 5. 5 is a factor. Here 5 comes left hand side, minus 5. That means a minus 5. If 5, you have to write a minus 5. If it is minus 5, you have to write a plus 5. I tell you the reason again. What's the number here? 5. 5 here it is. Plus 5 comes left hand side, minus 5. So you'll be getting a minus 5 right here. A minus 5. Next one, you can write that quadratic factor itself. You no need to factorize this one. What do you mean by the quadratic factor? Listen. This one should be multiplied by a squared. This one should be multiplied by a, and write the constant as it is. So 1 into a squared, minus 5 into a, minus 5a, and minus 14. See, if we multiply these two, definitely we will be getting this polynomial. Okay. Now the Lcm, here it is, that can be replaced by a minus 5 into a squared minus 5a minus 14. So why I didn't factorize this polynomial? Because you can directly cancel a minus 5. This only left out. You can write as it is, so that you no need to factorize this one. That is equal to a squared minus 5a minus 14. Even if you factorize this polynomial, that is also correct. How to factorize? That is very easy. You know how to do. The coefficient of a squared is 1. 1 into minus 14 is minus 14. The coefficient of a is minus 5. Product minus 14, sum minus 5. The two numbers are minus 7 and 2, correct? Minus 7 plus 2, that is equal to minus 5. Minus 7 into 2, that is equal to minus 14. For getting the linear factors, you have to consider the coefficient of a square. What is the coefficient of a square? Write 1. 1 into variable we have a. So write a 1 into a minus 7. 1 into a plus 2. That's all. So you can stop the answer at this stage, or else you can write a minus 7 into a plus 2. So problem number 5, subdivision 1 is over. Now I'll be teaching problem number 4, subdivision 1 is over. Now I'll be teaching problem number 4, subdivision number 2. Here we are given LCM, GCD and Q of x, or asked to find out P of x. Okay, write x squared plus y squared as it is. This one we have to apply the identity. We know that a power 4 plus a squared b squared plus b power 4 identity, you know very well. A squared minus ab plus b squared into a squared plus ab plus b squared. This is an identity. Instead of a and b, we have the variables x and y. Already this type, particularly this expression, we have factorized in the previous problem, isn't it? So you can directly write, instead of a and b, have to replace x and y. Come on, a squared becomes x squared, ab becomes xy, and b squared becomes y squared into a squared, that is x squared, plus ab becomes xy and b squared becomes y squared, over. And this one, x squared minus y squared, you can write as it is. Otherwise you can apply the identity a squared minus b squared. What is the identity for a squared minus b squared? A plus b into a minus b. So this x squared minus y squared, according to this identity, you can write x plus y into x minus y, factorized. Now x power 4 minus y power 4 can be written as, have given that identity. I write the identity over here. A power 4 minus b power 4, that is equal to a squared plus b squared into a plus b into a minus b. This is an identity for a power 4 minus b power 4. Instead of a and b, we have x and y. Just replace a by x, b by y. Come on, x squared plus y squared into a plus b becomes x plus y, a minus b becomes x minus y, and write this expression as it is. X squared plus y squared minus xy, otherwise minus xy plus y squared, same only. Okay, x squared minus xy plus y squared. Now P of x. We know that P of x polynomial formula Lcm into GCD by Q of x. LCM, here it is, x square plus y square into x square minus xy plus y square into x square plus xy plus y square. GCD, here it is, x plus y into x minus y, x plus y into x minus y, divided by Q of x, here it is, into x square minus xy plus y square. X square plus y square get cancelled. X plus y get cancelled. X minus y get cancelled. X square minus xy plus y square, x square minus xy plus y square cancelled. This expression only left out. What it is? X square plus xy plus y square. That's all. So problem number 4, both the subdivisions are over. So exercise 3.3 is completely over. I'll be teaching the next exercise in the next video. Thank you, children.